right, before we start, a little history lesson first. All right, a little history lesson. Friday, we went over circumference. That's the distance around the circle. And I gave you two formulas, pi d, which is what I like to use. And then I gave you a secondary one, which is 2 pi r. And I just want to quickly go over where that formula comes from. 2 pi r. All right, what's r mean again? Radius length. All right, so take a look at my second circle I have here, the big one. All right, everyone see the radius I drew in? If we had time, and obviously we don't have that much time, I would want you guys to cut out that radius and then figure out how many of those radiuses here, how many of these right here you could fit around the circle. And I did that for you already. So take a look. I cut that radius out and I said, all right, starting here to here, there's one. All right, that's the length of the radius. I could fit one of those. All right, and then I kept going around and I said, all right, I could fit a second one. I could fit a third one. I keep going. I could fit a fourth one. I could fit a fifth one. Hey, and then I could even get in a sixth one, right? And then everyone see the little piece I had left over? Not exactly a full radius, but part of one. So how many full radii could I get around the circle? 6. And then a little bit more. Not a full one, but a little more. Everyone agrees? And I said, all right, that's pretty cool. Let me go to a different circle. So I made this smaller one right here. And I did the same exact thing. I drew the radius in, cut it out, and figured out how many I could fit around the circle. And guess what it came out to be? How many I could fit around? 6 full ones and a little bit more. That happens for every circle. You draw in the radius, you could fit 6 radii around and a little more. Let me say that again. 6 radii and a little more. Grab your calculators. Circumference, the distance around a circle, is equal to 2 pi times the radius length. Do 2 pi in your calculator right now. Notice anything? There you go. Okay? Times the radius length. Because any circle I give you, you could fit 6 radii and a little portion of the radius to finish it off. All right, so that's where the 2 pi comes from. All right, just wanted to show everybody that before we started today. All right, I thought that was pretty neat, being an honors course. I'd like to show you that too. That's any circle you can fit 6 radii around, full radii, and a part of another one. Okay, so that's why the circumference is 2 pi r and not anything else.
So it's saying maybe like 6.2830 or whatever.
Radius
that
is
amount of radii?
Correct. In every circle can fit around a radii. Can fit around a circle. Yes, correct. All right. Yes, I know, kind of dorky, kind of neat at the same time, but all right, here's where the mind-blown part comes today. Your entire math career. Teachers come up, here's an angle, what's its measure? Your answer is always in degrees. It's been in nothing else but degrees until today. You can measure an angle in a different type of unit other than degrees, what's called radians. You can measure an angle in what's called radians. You ever see on your calculator, you probably remember 2 units ago, I'd always start off class with what mode you have to be in. What mode did you always have to be in? Degree. Well, did you ever notice that there is another mode right next to it called radians? And please you'll never have to be in radian mode until Algebra 2 next year. So don't worry about it. All right, but I just wanted you to notice that there is another mode next to degree. And that is because that's the other way to measure a circle. So first thing, what is a radian? How is a radian created? All right, how is a radian created? Let me show you how a radian is created. In every circle, you have a radius, correct? And any radii you draw in, what are you going to know about it in the circle? They're all the what? All the equal length, right? So let's say my radius length is 2 in this circle. If your arc length matches that radius, so if my radius is 2 units and my arc length is also 2 units, that is where 1 radian is created. So that angle right there is something degrees. I think it's about 53. I think it comes out to be. But it's also 1 radian measure. When the radius length and the arc length are exactly the same, you have created what's called a radian, 1 radian, which is, again, if you're interested, I think it's about 57.3 degrees. That's the conversion, all right? It's about that.
I'm a little confused. What exactly? So is the radian, is it a line?
It's an angle. It's another way to measure an angle. So this angle right here that I've created, Sophia, with those radiuses of 2, it's about 57.3 in degrees, and it's about 1 in radians, 1 radian. It's a new way to measure an angle. It's not a line or a segment. It's a new way to measure an angle in radians. Every radian has a degree equivalent as well. So 57.3 degrees is equivalent to about 1 radian. Yes, Radhika?
Could the angle of the radian change if the...
Okay, I'm going to get to that in a second. Yes, I'm going to answer that question in a second. Go ahead.
Why?
Why what?
Why can't we just use degrees? What's the difference? Like,
Okay, exactly. Here's why. And you're not going to realize it until tomorrow. I've given you 2 formulas already, correct? Tomorrow I'm going to give you another formula, but it only works if the angle's in radians.
Why does it only work if it's in radian?
It's only meant for radians.
Okay.
All right. So if you want it, so if I give you it in degrees, you can't use the formula. You're going to have to take that degree, convert it over to radian to use the formula tomorrow. So that's why.
Like, do we have to remember that it's 57?
No.
Oh.
You know, I was just showing for.
Yeah.
Go ahead. Keep asking questions here.
Oh, sorry. What did you say have to do the same?
Say that again.
What did you say has to be the same?
The radius and the arc length have to be the same. That's when 1 radian is created. Now let me show you this now. Let me show you a radius of 5, but an arc length of 15. How many radians are in that angle I just created now? Not 1 radian because they're not equal, but now 3 radians, correct. This angle would measure 3 radians. Okay, so it's all dependent on the arc length and the radius length.
How is that 3 radians? I'm sorry, I'm trying to...
Okay, well, if they're equal to, like I had 2 and 2, it's 1 radian, right? Well, now the arc length is 3 times the radius length. So I'm going to have 3 radians now instead of 1 radian. Okay? Here's what I need you to, go ahead, Anna, sorry.
Do you have like a decimal? Like if you have like a 3.2.
Correct, you could, yes. Yep. All right, here's what I need you to have the ability to do today. Go back and forth. If I give you degrees, what's it equal to in radians? If I give you radians, what's it equal to in degrees? Go back and forth. Because again, just like I spoke to Kyle about, tomorrow I'm going to give you a formula that can only be used in degrees. I mean, in radians. So I need to have the ability to convert. So let's talk about converting. First thing, before I show how to convert, I don't know if you guys have it on you or not. I have extra copies. Back in, I think it was when we did quadratic formula. I think it was similar triangles unit. I had given you guys this sheet, the reference. It's called a reference sheet. And I told you to hold on to it. I don't know if how many of you actually held on to it or not. You guys at home, if you need this, it's up on Google Classroom right now under Unit 10. All right, it's under Google Classroom on Unit 10. I have extra copies here in class if anybody needs one, because you need one. Anybody going to need one here? I will give you this. Hey, I am going to give you this on any test or quiz in this unit. All right, because there's 2 pieces on here that you'll need. So please keep it with you. Please keep it with you. Again, you guys at home, if you're coming in tomorrow, I'll give you your own copy if you need it. But for now, if you need a copy, it's up on Google Classroom under Unit 10. All righty? So I'll get back to that in a second, that sheet, because you'll need it. All right, so let's talk about converting. First thing, convert degrees into radians. All right, I'm going to give you a formula tomorrow where I may start the problem off in degrees, but you need it in radians to use the formula. So how do I convert? All right, how do I convert? You are going to multiply by a conversion. All right, you're going to multiply by a conversion. Everyone, go ahead. If you don't have it, I'll put it up on the screen right now at home. Does everyone see where I start on the right-hand column with degrees? It says degrees, and then it says 1 degree equals pi over 180 radians. Okay, 1 degree equals pi over 180 radians. That is the conversion I'm going to multiply by. So when I go from degrees to radians, first thing I'm going to do is multiply by that conversion on the sheet. Pi over 180. And you don't have to memorize it, even though I'm sure most of you are just going to use it so much that you'll know it already, but it is on the formula sheet. Again, where on the formula sheet? Degrees to radians. Degrees to radians. So pi over 180. And then the second thing you're going to do, and you'll see me do this, we'll do this together, reduce your fraction. Please stay with me through this first one at least, so I can show you the method to my madness. All right, number one, I have a 30-degree angle. How many radians is that equivalent to? So I'm going to take 30, my degree measure, 30, multiply it by the conversion, which is pi over 180. Now, take a look at what I'm about to do. All right, 30 times pi over 180. Look, you know how I feel about this, right? You know how I feel about all that. You're not writing all that out and saying that's how many you have a half a radian. No. We're going to clean this up. So when you give me your answer in radians, you're going to leave it in terms of pi to clean this up, because I don't want that sucker written out. Absolutely not. So we are going to leave our answer, our radians, in terms of pi always. So I'm going to leave my pi in my answer. And then here's what I mean by reduce your fraction. 30 over 180 reduces to what as a fraction? You can just go right to your calculator, type in 30 over 180, and the darn thing will reduce it for you, 1/6. So in radians, there's pi over 6 radians in 30 degrees. And remember, that's an actual number. I just showed you. 0.5235987756 radians. So basically half a radian in 30 degrees. But I don't want that. Let's clean it up a little bit and keep it in terms of pi. Okay? All right, let's keep going. Convert 45 degrees into radians for me. So same thing, 45 times my conversion, pi over 180. Leave your radians in terms of pi. Reduce your fraction, please. 45 over 180. So we're getting what? Pi over 4 radians? All right, 60 and 90, go ahead. So hopefully you guys for 60 degrees, pi over 3 radians. I'll let you finish up for 90 degrees. We should have gotten pi over 2 radians.
How do you get it? Like how are you simplifying the answer? Like
Well, I'm putting pi there, and then I'm doing 90 over 180. I'm doing 60 over 180. 45, because remember, this 45, like in number 2, the 45's in the numerator. So 45 stays on top. I'm really doing 45 on top, 180 in the denominator, and reducing that fraction. Okay? Everybody else, all right? Yes, Hannah.
I have 2 questions. Will the numerator always be 1 and then you can just put pi on top? Like, will that-
No, it could be 2 pi over 3. Yes, it could
And
be.
then also, so if you have like a graph, would you have to use this, or could you just see what the?
No, don't worry about the graph.
Okay.
Yeah, don't worry. That's next year. Yeah. Radhika?
How would you solve it if it was like 2 pi?
Okay, so let's, you want me to add in a number 5 here?
Yeah.
Yep. Let's say 135 degrees now. All right, so I'd still, ready? 135 times pi over 180.
Oh.
And now I go, what's 135
Yeah, that's.
divided by 180? 3/4. So this would turn into 3 pi over 4 radians. Okay, Sophia, you got your paw up at home. What do you need?
2 things. What is the degree measure that we're like converting? Like, what's that supposed to represent?
Could be any angle in the circle, any central angle in the circle.
All right. And I forget what the other thing I was going to say was. So.
Okay. And watch, trust, I got one more thing to do converting, and then I'll try to tie this into what we did yesterday with length of an arc, and I'll show you, hey, oh, geez, this is why I need to know how to convert. All right, so just give me a minute here to convert the other way now. So now is, all right, you know how to go from degrees to radians. You multiply by pi over 180. What if I give you it in radians now? And now this is going back to Radhika's question. As you can see here, Radhika, hey, 5, 6, and 7, I got more than just 1 in the denominator, right? So I got a little more than that. So what do I do if I give radians and I need it into degrees for some reason? All right, go to your formula sheet now. Everyone see where I start with radians and go to degrees on your formula sheet. Locate that spot right now. Everyone see that? You start with radians and then go to degrees. Now what am I going to multiply by? Not pi over 180, but 180 over pi. So I'm going to go back to degrees, I need to multiply by 180 over pi. And watch what happens when I do. So let's go to number 5. I have 7 pi over 6 radians. What would that be equal to in degrees? All right. Well, I take my radians, 7 pi over 6.
I'm confused. When you say multiply by 180 over pi,
Correct.
on the sheet for radians it says 180. Is it if you multiply that by degrees? So why would you multiply it by the radian?
This is saying 1 radian, right? Well, I don't have 1 radian here, Maeve. I have 7 pi over 6 radians, right? So that's why I'm multiplying. This is only if I had 1 radian. That's the same as 180 over pi. But I have 7 pi over 6. So however many radians I have, I need to multiply it by, ready, watch, here. If I had 2 radians, what would you have to do to 180 over pi? Oh, multiply by 2, right? If you had 3 radians, what would you do? Okay, but I don't have 1, 2, and 3, I have 7 pi over 6. So you're still going to tell me the same thing, right? Multiply it by 180 over pi. You okay?
Yeah.
All right. And now watch what happens. What do you have in the numerator and what do you have in the denominator? They cancel out. Because they should, right? I shouldn't have a degree. I shouldn't have a degree that's got a pi in it. So the pi's cancel out. And now you're just numerator times numerator. 7 times 180 over 6.
Wait, I'm really confused now. On the formula sheet, it
Yep.
says 1 degree is pi over 180 times radians.
Okay, but I don't have a degree. I wasn't given a degree. I'm given radians.
It's a conversion, not a formula. It was weird.
Okay, here you go. 1 radian is equal to 180 over, 180 over pi, right?
Yeah.
Okay, watch. I'll make a proportion out of it.
Yeah, but why does it say degree?
Because that's how many, watch, 180, because they don't want to write this, Kyla.
Is it not multiplied by any degree?
What? No, but isn't
Here you go.
radians trying to find out one?
There you go. There's my 57.3. But I don't want to write that on the formula sheet.
Okay.
So I cleaned it up and wrote it at 180 over pi. Okay? 1 radian is equal to 57.29, da da da. Look, we went over before, about 57.3. But instead of writing that on the formula sheet, it's a little too much. Let's clean it up and just write it as 180 over pi instead.
It's not being multiplied by degrees.
What's that?
I thought it was multiplied by degrees, like that's why I was next to it.
This-
like degree.
Okay,
doesn't make
here's the
sense.
problem. You guys are just seeing pi and you're automatically thinking radians. All right? When I multiply by 180 over pi, I'm essentially multiplying by 57.3. That's what you're doing. Because 1 radian equals 57.3 degrees. That's what you're doing. Every time here, we're multiplying by 57.3 degrees.
Yeah, I thought you had to multiply by the degrees. Like in the first, it says 1 radian equals 180, so pi degrees. I didn't realize it was a unit and not multiplying by the degrees.
Okay? So this ends up being, what do I have here? 210 degrees. All right, 3 pi over 5. Turn that into degrees. I understand. Hey, I get it, guys. I like all your questions. Keep asking. Because this is a totally new concept here. And I'll try to tie it all together here at the end with an example that you can't do. Pi's go again. And this one ends up being, what do we have, 108 for that one? And then go ahead and try number 7 on your own, but let's do number 8 together. $300 for that one. All right, what's different on this last one than the other 3?
There isn't a pi.
Okay. It's still radians though, isn't it? It's still 3 radians, isn't it? Not 3 pi, 3 radians. All right, sometimes the radians don't come with the pi with it because I don't need it. It's just clean, 3. I'm still going to multiply by what? 180 over pi. Except now, what's not going to cancel? The pi's won't, there is no pi to cancel. There's just that 1. So I'm just going to do 3 times 180 over pi, and I should have had rounding directions on here. Let's go nearest 10th. Let's go nearest 10th. And 3 radians is about 171.9 degrees. Okay, before you get into the homework, here you go. Let me give you this example. And please don't copy it down. No need to. We'll be doing enough of this tomorrow. Here's my circle. Anybody got a radius length they like? 4 inches. There you go. This angle in here, this central angle, 2 pi over 3 radians. What's the arc length? You got a formula for arc length that we've discussed? You guys got a formula for arc length? All right, tell me about it. Here we go. Arc length equals what? Angle measure over 360. Here's a problem though. That angle measure's got to be in what? I can't put 2 pi over 3 here. This has to be in what? What's your angle in now? So what do I need to do to it? If I want to use this formula, what do I need to do? Convert it. Multiply it by 180 over pi. What is that? 120, I think, if I'm doing the math quick. 120. All right. I can't do this formula without degrees. So that's why I need the ability to be able to convert if I'm not given degrees conveniently at the beginning of the problem. Okay? Tomorrow, I'll give you a formula that involves radians instead. All right, to find the length of an arc. And then you guys can choose which one you want to use. Tonight's homework, do not skip. Whine about the last problem that involves the clock. You guys can handle it. All right, it's a little thinking problem. All right, a little bit of a thinking problem. So you guys at home, I'm all set. You guys can get started on it, but you don't need to keep logged on. I'll see you guys tomorrow. All right, see you tomorrow. Good class today.